Hey there. Today, I'm happy to share a fascinating case study on how we're tackling a major challenge for LBM electronics in the U.S. electronics market through Greenfield Analysis. Let's begin by taking a quick look at the agenda for today's presentation, which includes overview, modeling approach, and the modeling results. LBM Electronics is a leading company with a strong presence in the U.S. consumer electronics market. It has 100 customers all over the U.S., and it also has 2 distribution centers in the U.S. right now, one in L.A. and another one is in Atlanta. Here's the business challenge. In order to streamline logistics cost and improve customer service, LBM Electronics has been contemplating addition of new distribution centers to its network. To lay the foundation for our Greenfield model, we have identified key inputs crucial for LBM Electrics, including products, sites, customer orders, Greenfield setting, and Greenfield service constraint tables. In this section, we will mainly talk about the modeling approach, which includes analyzing their business challenge. First, time to talk strategy. The study comprises 2 phases. Phase 1, Greenfield and Brownfield to determine candidate DC locations. Greenfield is mathematically find where the DCs are, and Brownfield is keeping the existing DCs and find new ones. Phase 2, network optimization by considering actual cost and customer service requirements to determine the optimal DC footprint setup. Moreover, we have also built the data automation process on Dastro for input data cleaning and model refreshing. Dastro is an integrated cloud-based ETL, extract, transform, load tool seamlessly incorporated into the Sophus platform. Users have the flexibility to utilize Dastro for connecting input data from diverse sources and transforming it into the required format for integration with the Sophus model. Dastro efficiently extracts, cleans, and formats the data, streamlining the process and saving valuable time and effort. With just a simple click, customer order data can be effortlessly refreshed within our model, ensuring up-to-date and accurate information. Model options is where you define, for example, whether the Greenfield optimization towards a volume and location-driven or customer location-driven, or simply determine the number of Greenfield DCs you want the model to choose, or a Greenfield service constraint. For the volume and location-driven approach, the candidate DC locations tend to be closer to higher demand customer locations. For the customer location-driven approach, candidate DC locations tend to be closer to higher concentration of customers regardless of their demand. For a number of Greenfield DCs options, simply provide a number of how many you want. For service constraint, simply define, for example, like at least 95% of customers need to within 400 kilometers from the DC now. Let's walk through different scenarios. We can create scenarios to assess the impact of 3 crucial business variables: volume and location proximity versus customer location proximity, varying the number of DCs, and adjusting service targets. The Scenario Manager in Sophus makes it convenient to configure these scenarios. We can utilize scenario items to modify key inputs within the model and create scenarios conveniently through drag-and-drop actions by combining these scenario items. Let's jump to Sophus to show you how the model is set up first. By leveraging Dastro, we seamlessly integrate and update our data. Let's explore the predefined scenarios and options. Here are the scenarios. In the first scenario, I have used the scenario items to consider existing facilities and the number of Greenfield quantities. We can always create different scenario items for different Greenfield quantities, like this. You can also do it at the Model Options under the Greenfield section. For the customer location scenarios, I have also updated all the demand to 1 if LBM wants to weigh every customer equally. The scenario 3.1 to 3.4 are used for testing different Greenfield result at different constraints. Let's solve them. All of these scenarios can be solved in a few seconds on Sophus. We can also create interactive maps on Sophus to see the different scenarios outputs. I have created one here to see the results on the map. This is the baseline. This is the recommended DCs after Greenfield and Brownfield. We can also create customized views. Like here, I connected the Greenfield site summary table and Greenfield flow table to see all the Greenfield DCs throughput level and distance to each customers. Besides, Sophus also provides custom BI features for user to develop their custom BI to tell a better story to others. My BI has a line chart, a map, and a table to provide an overview of Greenfield output at one place. Let's quickly recap our features on Sophus. After we solve the scenarios, we can create interactive maps to display the results. Besides, we can create views from all the tables for a data analysis. Like here, I have created the Greenfield sites and their throughout quantity from 2 different tables. Last, we can create a custom BI for model presentation. Enabling us to display multiple charts simultaneously for enhanced visualization. Let's come back to Sophus to see how we can progress from Greenfield to NO. After we run all of these scenarios, now we have a lot of candidate DCs for LBM. We can go to Greenfield Site Summary to add all of these DCs to Site Table, and we can then add some more detailed data like fixed startup cost, operation cost, and closing cost for these DCs to make the Find Site selection decision for LBM. I will take these actions. First, adding these Greenfield sites to the Sites table. We can do it from here. I have already added some costs for all of these DCs, as well as the production inventory, sourcing, transportation policies, and variable cost, handling and shipping, to the model. Lastly, we will add customer service constraints to ask all the DCs needed to serve 90% of demand within 1,000 kilometers. See what DCs the model will select. We will not use the site constraints for this scenario, but we can always use it to limit the DC selection numbers. We can solve these scenarios now. The scenarios have been solved. Let's compare the results. Open map. As we can see from the map, if we want to keep the 2 existing DCs, the model will select 6 other Greenfield DCs in order to achieve our requirement and minimum cost. If we allow the model to close the existing DCs, the model will only select to open 6 DCs. Let's compare the cost. SC 4.1 sees 2 existing DCs to remain, and 6 new DCs are opened. The main costs are operating cost and transportation cost. In comparison, SC 4.2 sees all existing DCs are closed. Instead, 6 new DCs are opened. This means an increase of startup cost and closing costs, but there are large savings from the cheaper operating costs due to the better locations. The second scenario has $370,000 cost less than the first one because of closing the existing DCs. If LBM wants to take step-by-step approach, for example, open 1 DC per year, then we can add scenario to use site constraints to achieve it. For example, if we limit to 3 DCs, the next DC will open in Fort Worth. If we limit to 4, the 4th one will open in Fort Wayne. We can check the map to compare. Let's take a quick recap. Like we did in Greenfield, we can create maps to see all the NO selected sites and flows. And finally, the custom BI would be perfect for the summary of the output. If you have any questions, you can always reach out to support@sophus.ai. Thank you.